Here are some of the most challenging construction endeavors around the globe, ranging from constructing a railway in the scorching heat of a desert to enhancing a research station in one of the most frigid locations on Earth. Additionally, we have the colossal task of developing the largest infrastructure project in the Himalayas, reaching elevations of up to 3,700 meters. Another remarkable feat is the creation of one of the world's biggest artificial excavations. These projects exemplify extreme construction ventures worldwide. Number 5. The Rothera Research Station. Located in one of the most remote and inhospitable regions on Earth, with temperatures ranging from 5 degrees to minus 40 degrees Celsius, the UK is currently undertaking a colossal project worth $415 million. Every element involved in this venture, including workers, equipment, and construction materials, had to be transported from the UK to Antarctica, covering a distance of approximately 11,000 kilometers. But what exactly is being constructed in this challenging environment? This site serves as the largest British research station dedicated to polar exploration and supports numerous ongoing scientific endeavors in collaboration with the Netherlands. Among these projects is real-time research focused on studying climate change. To accomplish this, continuous monitoring of Antarctic weather and wildlife takes place, enabling the development of precise climate change models that can forecast rising sea levels. Despite the extreme weather conditions, additional buildings have been added over the years to facilitate efficient research operations. What was once a small base accommodating only 4 individuals has now transformed into a complex capable of hosting up to 130 staff members, working at full capacity during the summer months. For approximately 4 years, the British government has been engaged in the most expensive state-funded initiative in Antarctica since the 1980s, known as the Antarctic Infrastructure Modernization Program. As part of this $415 million project, the Rothera Research Station is being upgraded. Many of the existing structures at the station were deteriorating and required renovation. Furthermore, a new $55 million wharf was completed in 2020 to accommodate the new polar research vessel. Additionally, construction on the Discovery Building commenced and is expected to be finalized in 2024. The Discovery Building serves as a modernized facility for scientific operations, featuring energy-efficient systems that minimize the station's environmental impact. With 2 stories, it combines field expeditions, medical facilities, and office spaces while replacing several older structures. Number 4. The Etihad Railway Megaproject. Transporting you from the icy realms of the polar regions, we now venture into the scorching Arabian desert, where the UAE is presently engaged in constructing the Etihad Railway. Once completed, this colossal project, valued at $11 billion, will establish a 1,200-kilometer rail network linking the UAE to Saudi Arabia, spanning from the Guwaifat region of Abu Dhabi to the Fujairah port on the east coast. This extensive infrastructure endeavor represents a fraction of the ambitious plans that the Gulf Cooperation Council (GCC) countries, Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, and the United Arab Emirates, have envisioned for their nations. Given the heavy reliance on oil within the GCC countries, their economies suffered significant setbacks during the 2008 financial crisis and the subsequent COVID-19 pandemic. To overcome these challenges, the GCC states are collaboratively working on a long-term solution, a colossal $100 billion railway network designed to enhance connectivity between their ports and industrial hubs. This strategic initiative aims to diversify their economies and reduce dependence on oil. However, let us delve deeper into the UAE's Etihad Railway Megaproject, which presents distinctive and extreme challenges due to its location in one of the world's hottest and harshest regions. With daytime temperatures soaring up to 50 degrees Celsius, construction workers are compelled to toil during the relatively cooler nights, where the temperature hovers around 30 degrees Celsius. Yet, the blistering heat is not their sole obstacle. Being situated in the heart of the desert, the construction site contends with vast quantities of sand. During intense winds, substantial amounts of sand settle on the site, impeding progress and potentially damaging the railway infrastructure. As a preventive measure, the nearby sand dunes are gradually transformed into clay, although this process takes several years. An alternative solution to combat the sand influx is the planting of numerous trees in proximity to the railway. These trees serve as natural barriers, shielding the railway from sand accumulation. The Etihad Railway Megaproject will be constructed in 2 stages and is expected to be fully operational by 2024. The first stage, initiated in 2009, involves the construction of 2 tracks spanning 264 kilometers, connecting the Shah and Habshan gas fields with the port of Ruwaist in the western part of the United Arab Emirates. Additionally, the railway aims to contribute to the country's environmental efforts by reducing its carbon footprint, which currently ranks among the highest globally. A single train journey on the Etihad Railway is equivalent to removing approximately 300 trucks from the roads, resulting in a significant reduction of carbon dioxide emissions by 70 to 80% compared to truck transportation. Phase 2 of the project will extend the rail network by an additional 600 kilometers, connecting the East Coast with other vital industrial regions. Number 3. Norway's new coastal highway. Let's explore a location with a more favorable climate. Norway is renowned for its breathtaking natural scenery, including picturesque coastal towns, majestic mountains, and dramatic cliffs. However, navigating through this stunning landscape poses significant challenges. Currently, traveling from Trondheim in the south to Bergen in the north takes approximately 21 hours and involves 7 ferry rides. To enhance transportation connections to the western and northern cities, and thereby stimulate the economy, Norway has undertaken a remarkable $47 billion highway upgrade. This groundbreaking project will introduce the world's first ever coastal highway, featuring innovative elements such as floating bridges, floating tunnels, and the Rogfast Tunnel, the deepest road tunnel on the planet. Construction on the Rogfast subsea tunnel, the first of these ambitious undertakings, commenced in 2018 with an original completion target of 2026. However, due to cost overruns, the project has been delayed until at least 2031. Spanning nearly 30 kilometers and plunging almost 400 meters below sea level, this subsea tunnel will claim the titles of the world's longest and deepest of its kind. Nevertheless, the most challenging and ambitious phase of the entire coastal highway megaproject is undoubtedly the Sognefjord crossing. Sognefjord is Norway's largest and deepest fjord, stretching over 37 kilometers in width and reaching a staggering depth of 1.3 kilometers at its lowest point. The Sognefjord crossing poses several difficulties, including its immense dimensions and the regular passage of numerous ships through the fjord. According to regulations, any crossing must accommodate a shipping lane that is at least 400 meters wide, with 70 meters clearance above sea level and 20 meters clearance below sea level. In light of these considerations, the project team has devised several ideas for tackling this challenging fjord crossing. The first concept involves constructing a conventional suspension bridge with a span of 3,700 meters. Such a lengthy bridge would require support towers standing at a staggering height of 450 meters, surpassing even the Empire State Building and claiming the title of the world's tallest bridge structure. The second idea revolves around building a floating bridge, which would need to be adjustable to allow ships to pass through. This poses significant engineering challenges since the bridge would only be anchored to each shoreline. Another proposal is the implementation of a submerged floating tunnel. Given the extreme depth of the Sognefjord, the tunnels would be suspended from floating pontoons, enabling unobstructed passage for ships. Alternatively, a hybrid solution combining a floating pontoon bridge and a portion of the submerged floating tunnel could be considered, ensuring ease of ship navigation. If realized, this concept would represent a pioneering achievement, the first of its kind worldwide. Number 2. Tibet's high-speed railway. China is constructing an extremely challenging railroad in the remarkable natural setting of the Tibetan Plateau, often referred to as the roof of the world. With an average altitude of over 4,500 meters and surrounded by the world's highest mountains, including Mount Everest on the Nepal border, this region presents a unique engineering feat. The current focus is on building a 1,800-kilometer-long electric high-speed train connecting Tibet's capital, Lhasa, to Chengdu. The project is divided into 3 sections, with 2 sections already completed. The Lhasa to Nangshi Railway alone, spanning 400 kilometers, required an expenditure of nearly $6 billion. This section includes 47 tunnels and 121 bridges to accommodate the varying altitudes. Due to the extreme heights, the trains feature specialized technology, such as an oxygen supply system and specially designed windows to protect against intense UV exposure. However, the most challenging phase lies ahead. Construction of the middle section, which extends over 1,000 kilometers between Yayan and Nyingchi, began in late 2020. This area is prone to frequent earthquakes due to the collision of the Indian and Eurasian continental plates. Additionally, landslides, snow avalanches, and floods are common in the region. Building on Tibet's permafrost ground, which expands during winter and contracts during summer, presented another obstacle. Consequently, approximately 90% of the railway line comprises viaducts and tunnels, making it a highly expensive endeavor. To ensure the safety of construction workers, more than 100 temporary medical facilities have been set up along the rail route. These facilities provide immediate medical assistance as needed. Apart from coping with the exhausting work at high altitudes, the workers must also endure significant temperature variations. Temperatures inside the tunnels can reach up to 45 degrees Celsius, while outside, the temperature is often 30 degrees Celsius lower. The entire project is projected to be completed by 2030. Once finished, it will greatly facilitate access to this awe-inspiring region and represent a significant advancement in China's infrastructure development goals. Number 1. Diamond Mir Mine. The Mir Diamond Mine, located in the Siberian region of